In this tutorial, we're simulating crack growth in a 3-point bending test using XFEM in Abaqus. You'll learn how to model geometry, define material properties with fracture behavior, set up XFEM crack initiation and propagation, and analyze how the crack evolves under bending load. We'll cover everything step by step, from part creation to meshing, boundary conditions, and post-processing with fields like STATUSXFEM, PHILSM, or PHILSM. So let's get started. Okay, let's start with creating the part. Create part. We name it beam 3D deformable solid extrusion and continue. We want to create a simple beam just like this, a rectangle. Then we add the dimensions. The length must be 80 millimeters and this one should be 4, and scroll button, this one, which is the width, must be 8. So we have the beam. Now it's time to create the support or span. I would call that the span. It should be 3D, discrete rigid, solid extrusion, and continue. Now we create something like this. This should be 8. And this one must be 4, scroll button once more, and this one should be 8 as well. Now this is the span or support. Then we need to create the crack. The crack must be 3D deformable shell extrusion and continue. We just want to create a simple line just like this. This should be 1 millimeter. 1 is enough. Okay, same as previous one. The depth should be 8. Now we have all the parts, crack, span, and the beam. Now it's time to go to create the materials properties. We create the material properties, general density. The mass must be 7.8 E-9. Then we go to the mechanical, elasticity, and elastic. 210,000 and 0.3. This is for the elastic. Now we should go to mechanical, damage for traction separation loss, and max PS damage. Let's put the value of 120 megapascal. Don't mind this if you're not using the 2024 version. And we need to go for damage evolution. Put this one on energy, and the mode should be power low, and 40,000 joules. We copy that and paste it here. Also make sure to put the power on 1 here, and okay, now we need to create the damage stabilization cohesive 1E minus 5, and we have everything: density, elastic, max PS, damage evolution, and damage stabilization cohesive. And okay, now we need to create a section. Must be solid, homogeneous, and continue. Okay, and we select this one. Then we assign the section to this one. Just uncheck this one and okay, and done. We don't need to create sections or assign materials properties to span or the crack. And okay, let's go to the assembly. We would have an error here if we want to have the span alongside the crack and other things. As you see here, it says a solid rigid part cannot be instanced for the assembly. Now to fix that, we go back to part once more, and we need to go to the span, left click and hold on this one, and go to the create shell from solid. We select this one and done. And as you see, now if I cut this, it is hollow. Before that it was a bulk, but now it is hollow. Now we can create that in the assembly. Another thing that we can do here is also to create a reference point. So I would like to create a reference point right here So in that case, we don't need to create an interaction of rigid body to call this a rigid body. So this is the discrete rigid and can be used directly. Okay, let's go to the assembly. Now, as you see, if I select everything here and click on OK, I can create them. Alright, now it's time to translate them. First, this one, scroll button here, can go here, and that's it. Now I need to translate this one, select and this reference point can go here. Now I need to create more of this. So by here, span, I click and apply. Then I want to do that once more, just like this. Then here, scroll button, reference point, then you can select this one and put it here, a simple translation, and this one the same thing. Here can go to here. Now we have our assembly. The assembly is done. Now we can go to the step. Now we want to create a step. Step 1, initial, static, general. Then we can go here, 1000. 3 more zeros, should be 1 million. This can be 0.1, 1e minus 9, and 1 as the maximum is okay. Then okay. Now we're not done with it yet. Let's go to the field output manager, and here from status you should toggle this one on, status, in order to see the separation. Plus we need to go to the failure and fracture. You go all the way down and PHILSM and PSI-LSM, check them on, and okay. Now we're done with the step. Let's go to the interaction. We need to create an interaction property. It should be contact, continue, mechanical, tangential behavior, and we would like to have a penalty 0.15. And from mechanical, normal behavior, we would like to have a hard contact. And okay, now we need to create interactions. From this one, step 1, surface to surface contact. But in this mode, we're going to select the surfaces manually. I don't want to do that, so there's an easier option to do, is to go to find contact pairs. If I click on this one and find contact pairs and select them here, you see it shows the contacts, and if I click on OK, and the interactions are created. As you see here, we have one contact between these two, and we have one contact between these two, and there's another one here. So we do have the contacts, and it made our life easier. Now I need to create one another interaction from special, and in the crack, create, select XFEM and continue. We select the crack domain, then we toggle this one on, crack location, and we zoom in here and select the crack and OK. Then OK here. Now we need to create another interaction here in the step initial, XFEM crack growth, and this should be crack 1 and OK. And as you see here, we selected this crack to grow. Okay, this is done. As far as I'm concerned, there's no interaction to be created. Now let's go to the load and boundary conditions. Okay, this is easy. We create the boundary condition from here. I hit create. We can create one from the encast mode. Continue, we select this one, we hold shift and select this one, these two reference points, and done, encast, and OK. Now we need to create another one from the displacement and rotation. Continue, I select this one, and done. Let's check all of them here for the initial step. Now in this step 1 we can modify that, so I'd like to put the value of -8, and okay, it means this span would displace 8 millimeters the opposite of y direction. And this is the load and boundary condition, and we're good to go to the mesh. Now we need to select part, this one. First we need to assign mesh control. We select this and done. Let's put this one on quad and structured. Okay, then we need to set the part. 0.8 is okay, and yes, now this one is meshed. We can go to the beam here. We need to select this one, the same number, 0.8, and okay. Let's create it. Yes, and now if we go to the assembly, you see as we selected the same global set size, these nodes are attached together. So here is fine, and here are in the same line. We check this one is also in the same line, and here also the lines are in the same one. If you see a mismatch between the two, it means the numbers are not correct and needs to be corrected. Okay, the mesh is also done. Let's go to the job, but before going to the job, I want to ask you a favor. If you enjoyed this video so far, please drop a comment down below. It's totally free for you, but it helps me grow faster and motivates me to create more videos like this for you. Okay, let's create a job. Here we create a job, we can name it 3-point bending XFEM and continue. Okay, then submit the job. It says the following part doesn't have any sections assigned, is okay, and you submit the job. Okay, let's take a look at the results quickly while the job is being run. And yeah, I think that's enough for now. We can terminate the job. From here, I click on kill. Yes, the job is terminated. It probably be aborted later due to the very coarse mesh we have here or the high displacement, but it's totally fine because this video has the educational purposes. It's up to you to modify it for your model. Alright, let's take a look at the animation. Just like this, as you say, here it goes down and the crack grew. Let's stop it here. From option, comment, we can go to the free edges and we can see the crack growth better. And from here, I would like to put it on this one to see that in a slow motion pace. Put it here, then from the side view, and there we go. Here the crack is propagating all the way to the top. Yep, and we can also see other things here like PHILSM or PSI-LSM. I already explained them in the previous video what they are and what do they mean. Please check the video. I put the link on top right here, and this is the contour of PHILSM. Let's go to the very end, and we have the contour of PSI-LSM, and here as you see the crack propagates. And that's it. If you enjoyed this video, please smash the like button and subscribe to the channel to see more videos like this. And if you want to learn welding simulation, click on the video on screen before it ends and stay tuned.